been unbeaten for like 2 years.
All right, so now that you guys had fun with the midterms, let's do a little bit of a lecture and a little bit of review. I'm going to talk today about the last type of loop you'll encounter in C++. So we talked about while loops and do while loops 2 weeks ago. I'm going to review those real quick and give you guys a little bit of a lab to practice that with. As well as we've talked about like if statements and conditionals. The most common loop that I use every day, the thing that like is kind of like the Phillips head screwdriver of game development for me, are the for loops. And there's like 2 parts to for loops. Today I'm going to focus on just the syntax and the usage of a basic for loop. Next week I'm going to structure the lesson plan a little differently. We're already on, this is week 6, right? 6. Yeah. So we're already in week 7, 8, 9, 10. So we have about 4 or 5 weeks. Like the last week is kind of a toss-up as far as what we're going to do. So after I teach you guys for loops, we're going to start jumping into how to use all the things that we've learned so far and combine them with a new concept called arrays to get things showing up in game visually without using text boxes. So we've been using like a console for now. I say this because for loops are kind of like one of the more important loops that you'll learn. And it's not because it's functionally any different really from a while loop. A for loop is just like a while loop. It loops some number of times. The only difference is that a for loop is so common, you write them so often, that it's something that's worth learning in an environment that's really related to game development. So today we're going to be doing a little bit of practice with for loops just without like any context with how we would use them for game development. And then next week we'll go into more detail about why those things are so important. For me, the typical usage, why for loops are so much more useful, is because they do one very specific thing that's very well, which is loop some number of times. And loop like, I want to loop like 3 times, or I want to loop like 10 times, or I want to loop over every object in my inventory, or I want to loop over every player that is in the game, or I want to loop over every enemy that I see. Or I want to loop over all the cover objects that I can take cover against. Or I want to loop over every bullet that I fired. Those things have a distinct count of things you want to loop over. And that is so common when you're doing game development that for loops are by far, like I don't know, I would say probably 99 out of 100 loops I write are for loops. So they are so common because you do so many things that involve multiple objects. So we're going to spend a lot of time on these. I'm going to talk more about them next week as well. And so hopefully this is something that will become the start of kind of cool game development. We're going to use something called SFML next week. Okay, so you guys did a midterm? So I want to review these things kind of briefly. I'm going to run through some slides of what we had done. We reviewed what break and continue did. So break and continue are 2 keywords that you can use to break out of a loop early. You can still use those in for loops, just giving you a heads up that those are not just for while loops. Those are for any type of loop. You can break and continue. And remember that break, if you put it on a line, will immediately exit the loop, while continue will immediately restart the loop. Okay? Those are what those 2 things are. We talked about logical operators like and or, and the exclamation operator, which is not. And we talked about how to combine them. You guys actually answered quite a few of them on the midterm, right? Logical operators, how to combine multiple conditions to get a single true or false value. I gave you guys a bunch of examples. Like if you had this really complicated statement, it's either true or false. Like even if you didn't know, you had a 50-50 chance of guessing whether it was right or wrong. I talked about game loops. So running through a game, why loops are important to game loops, as well as how to generate random numbers. So let's go a little bit more detail here. It's an example of the program that we used for a finicky counter. So remember, we created a program that lets us skip numbers. Right? So this is our while loop that lets us count up to the number 10, but it skips over the number 5 by using a continue statement, and it breaks out of the loop as soon as the count is greater than 10. Right? Those are the two commands. We combine those with if statements to control how the loop runs. Okay. We also talked about the various logical operators. Again, these give you control over combining multiple conditions. I gave you some examples of like why you would use these in games. For instance, if you want to be able to cast a spell, you need to have enough mana, and you need to be alive, and you need to be the right class, and maybe you need to be on the ground. Like for instance, in Overwatch, some of the conditions we use for emotes. We have this like radio menu which I made in game. So if you ever press C in game, that's what I did. One of the things that I did. If you press C in game, and there's kind of a radio menu that shows up, lets you try to emote in game. So there's two conditions that you need to satisfy before you can emote. And literally, what you see in the what we call our StateScript editor, which is like visual scripting, is we see a condition here that says, hey, in order for you to be able to emote in Overwatch, one, you need to be on the ground. So we don't let you emote in the air. We used to, which is a bug. And then two, you actually have to have an emote equipped. So you have to have both of those things. If you have an emote equipped but you're not on the ground, you can't use it. So conditions here are really important because most oftentimes it's not just one thing that you need to control your behavior of your game. You need multiple things that tie in to determine whether you can do something or not. Yeah, these are pretty useful. And or is going to be if either of those things is true. So a couple examples. So in the case here, if you have an AND operator, and this is your expression over here, if your username is smeyer and your password is civilization, what are the various results that you can get based on inputs? So if your username is equal Sid Meier, cool, and your password is equal civilization, then the result is true. If your username is Sid Meier but your password is not civilization, then you can't, that result is false. And notice here the trend is that you have to have both of these be true in order for the whole thing to be true. Anytime that you actually have one of these things be false, the whole thing is immediately false. And that's actually a C++ feature here that you guys need to realize is happening, is if I get here, and the username for Sid Meier, if this is false here, if my username is like Keith Myron here, it never even asks if the password is civilization. It just fails immediately. So C++ that's called short-circuiting, where it'll find out right away that if that thing is false, nothing in the rest of the expression will matter. It doesn't matter what the rest of it is. And we actually use that a lot. There's cases where we have a statement like this, and we don't even want it to look at the next thing because maybe it's expensive. For instance, the emote one is a perfect example, right? We need to A, know if you have an emote equipped, and B, know if you're on the ground. It's not free to tell if you're on the ground or not, right? Like if in a game, so the way that you tell in a game, so this is, I'm gonna take a little bit of a sidetrack to talk about how games figure out you're on the ground. You guys play games that have jumping in them, hopefully, right? Super Mario, right? How does the game know that you're allowed to jump again? Like except forget about double jumping games, right? Think about like a game like Fallout or a game like Skyrim where you can jump once. You have to jump again, right, when you're on the ground. Or even Call of Duty is another one, right? How does it know that you can jump again? Well, it tells because we use what's called raycasts in games. So raycasts are also really common. It's imagine like a 3D world. Imagine like you have a laser gun, and you can fire that laser gun. The laser gun, though, doesn't do damage. It just tells you information about what you shot. Okay? So a raycast is like a laser gun where you fire a ray in the world, and if that ray hits something, you can tell whether it hit an object, what type of object it hit, where it hit, the normal of what it hit. The normal is the direction of the facing. So like the normal of this wall is pointing out this way. It's a line that's perpendicular to the plane that you hit. So the normal of the floor is pointing straight up. The normal of the wall is pointing that way, right? So that's also really important because a lot of times you want to do ricochet shots. You use the normal a lot in game development for dot products. You also use the normal for lighting, but that's a side tangent. So I'm shooting this laser gun, which is a raycast, and tells me what I hit. So the typical way you do things is when in a game, you're constantly doing raycasts at the floor. You're basically shooting this laser gun at the floor as you're going, right? Like you have this raycast that's going every frame and figuring out whether you're on the ground or not. Because what if the floor falls out from underneath you, right? You want to know that you're no longer on the ground. You want to fall through. What if you're in the air and you shoot down? Well, the thing is, you can control the range. It's kind of like a lightsaber in a way. You can control the distance of that laser gun. By default, you can have things like shoot the entire distance of the game. That's very expensive to do. So this ray gun actually costs more time the farther it goes. So typically when you're trying to figure out whether you're on the ground or not, you have a ray cast that's maybe about this high off the ground, let's say, like starting from like mid-level and going down to the ground. And the idea is that if you jump, you're constantly doing that ray cast, and that ray cast is saying, hey, I'm not on the ground anymore, which means it will tell the game that you're not on the ground, so you can do things like disable the emotes in Overwatch, right? So in Overwatch, we know that you're on the ground because we're doing these ray casts down. So all that combined means that I have this condition that says, hey, you need to have an emote equipped, and you need to know if you're on the ground. The reason why that's important is that if I don't have an emote equipped at all, if I didn't unlock one, I don't care if I'm on the ground or not at all. It doesn't matter if I'm on the ground or in the air. In fact, I don't actually want to do that raycast at all if I don't have an emote equipped. So in the case of Overwatch, you want to make sure that you're setting up your conditions here so that you're keeping in mind how short-circuiting works. Because if I had swapped the order, let's say I'm just doing a raycast first and then figuring out if I have an emote equipped, you're wasting this raycast. Because what if you did the raycast, figured out that, oh, I am on the ground. Oh, but I didn't have an emote equipped. It's worthless. It basically, you're spending cycles in the game. You're spending time doing work that you shouldn't be, which means that your game isn't running at 60 FPS, which means that your game isn't feeling like it's a polished game. So keep in mind that's all the things go into the expression. And the same rules apply for the OR. So OR is kind of like, it's a combination of conditions which says if either of these conditions are true, the whole thing is true. Right? So if the username is guessed or the password is guessed, then the whole thing is true. So in these cases here, notice that in this case, both of these are true. So the whole statement is true. And in here, only one of these is true, but the result is still true. And on the third line as well. Notice, though, it doesn't matter if one or more are true. As long as just at least one is true, the whole thing is true. So again, C++ will short circuit this expression. It will look at the username here. And if that thing ends up being true, it doesn't even look at the rest of it. Okay? It doesn't need to. It doesn't matter what the rest of that expression is. So again, think about that in mind. If my username is guessed, it never even looks at password. It just says, you're good to go. You're true. All right, and then here's not. It's pretty simple. It's the ability to reverse the result of something. The reason why we use this, why would you ever want to flip something as opposed to just having that thing return the right thing? So a lot of times you write one function that tells you write one thing that tells you whether, let's say I'm writing something in Overwatch that tells me whether I'm alive or not. How can I tell if I'm dead with that one thing? I don't have to write anything else. I literally just say, am I alive? And then put a not in front of it. That means that I'm dead. Yeah, I'm either alive or dead, those two things. That's why this thing is actually really useful, because you don't have to write the code for every condition. If something is either true or false only, like you're either alive or you're dead, or you're either on the ground or you're not, you don't have to write lines of code for both. You do one, then you just flip the result, and you get to save some time. Like reloading is another thing. How do I tell if I'm not reloading? Well, maybe I wrote the code to say, I know when I'm reloading, so all I have to do is say, hey, let me know if I'm reloading, and then reverse it, and that way I'll know if I'm actually not reloading at all. So this expression, this not is a little simple thing, but it saves you a lot of time. It allows you to have control over a function and not have to write a bunch of code over again. So then we talked about a little bit about game loops. So this is a program which is Guess My Number. And Guess My Number is a program that loops until you guess the program correctly. Okay? So Guess My Number is an example of a very simple game loop. And every game you play has some kind of game loop in it. And a game loop is basically a program is running until you're telling it to quit. Whether you tell it to quit because the game is shutting down because a player quit, or whether you're quitting the game here because you actually won it, doesn't matter. But the loop is set up that typically you do this in this fashion. You figure out whether they're using a gamepad and what inputs they're currently pressing, or whether they're using keyboard and mouse. You update that game. Then once you update the game based on their inputs, like maybe you move the player forward, or maybe you start reloading, you then draw the results of that. And then after you're done drawing the results of that in the update display, you figure out whether your game is done or not. And if your game still should keep going, in most cases it does. This happens very frequently. In Overwatch, this happens 60 times a second. If you uncap the frame rate, some people run at 300 frames a second, like in loading screens, or 150 frames a second. That thing will keep looping until you're basically done and you shut down. So to apply that example to the Guess My Number game, this is what the loop actually looks like. So you have this ability to pick a random number, let the player guess, tell the player if they guess too high or too low, and then as long as they haven't guessed the number yet, just repeat that all over again. So if I go here, all right. 37. Okay. So, but do you see how that works? If I just keep typing in the same number, this thing will keep playing no matter what. There's no end to this. So it's a guess your number game, but it actually, the way this thing works is very similar to an actual game loop. And if you take a look at this, it's actually pretty similar to how like a lot of game systems work, like Pokemon is a good example, like, or any Japanese RPG. Take a look at like the original Final Fantasy, Shippuden, Ultimate Ninja Storm 4. Sure, like every game has some kind of loop like this, an input loop. So this right here, the numbers that I'm typing in are happening what? Like how fast am I typing in the numbers? Maybe like 1 per second. I'm currently playing a game that's running at 1 FPS, right? So you imagine this loop though. Imagine instead of me typing in numbers, this is you pressing like W, A, S, D. Maybe this thing is not running at like 60 frames a second. The difference is that this is like a turn-based game. It waits before it runs my next input, but Naruto doesn't wait. It just says like, keep taking your inputs all the time. So this loop here is actually exactly how we're going to be setting up our game loop. I enter a guess. Imagine maybe this is me pressing like reload on an FPS. What would happen is I would take that reload, start doing some logic to figure out whether I can start reloading or not, and then draw the reload animation. Maybe it takes a few seconds for me to actually get to the point where it actually reloads. But this turn-by-turn thing, instead of me entering a number, imagine me like playing Pokemon and me picking an attack to do, right? Like what attack do I want to enter? Flail. Splash. Do something, and then it returns me the result. This turn-based game, or a Final Fantasy game. So game loops are going to be a little bit more clear next week because I'm going to show you guys the first example. And typically a game loop involves an update step where you get input from the player. And once you get input from the player, you do stuff with that input, whether that's move characters in the game, or deal damage, or take damage. Then when you're done with all that stuff, the final thing you do is you draw that result to the screen. And that's the piece that we're missing right now. we're not doing a draw step. We're actually just doing a update step, and we happen to be writing that stuff to the screen. Okay. Any questions about game loops? I mentioned this 2 weeks ago, but it might have been a little bit hazy. We're going to get into new stuff today. I think I should give you guys a break. Because not everyone has taken it. I actually really wanted to do this review. So how about this? I'll give you guys like a short review problem. And then once you're done with the review problem, then you can go on break. So you can actually do a little bit of programming today. I'm going to put this up on Zool here. I'm going to put it in the SDVA 103 folder. And let's just do number 1. So there's a lab in the Zool folder. Please just do number 1. And if you feel like you want to, you can try number 2 as well. But do number 1, and then you guys can go on break.